Hello, my name is David Holmes. I'm here to talk about the problem of SSL Outbound Visibility, right? So an interesting problem, and we'll talk about some solutions. Right, so this is a problem a lot of people know about, and it has to do with malware. Let's draw a little malware guy here, a little malware server. He's angry. Malware is the #1 threat to the organization today, to the enterprise. People know this, been the #1 threat for 5 years running, whether that's ransomware or some kind of APT. So people know this. So let's take a look at drawing some users in your data center. Here's Sally, we'll make her female. All right. Okay, good. And maybe William over here. There's William, hello, and Vigo. All right, so these are users in the data center, right? And they go out to the internet all the time, and they drag back all kinds of malware, because that's just what they do, right? So they used to go out with HTTP, bring back malware, and everyone, right, gets infected, major problem. So there have been all these cool tools over the years developed specifically to look for malware in these types of connections. And if we were to draw some of them, and I'll just use sort of standard industry terms here, for example, next generation firewall, or the new kid on the block is sandboxing, right? Some of you might know that as FireEye, or maybe IDS, IPS, older technology, but being repurposed to look for malware. And then a lot of people have a data loss prevention system. And then many administrators use a web gateway. Right? So all these cool technologies looking for malware, try to prevent malware to get in the system. So what's the problem? Right? We've got all this cool stuff, we got budget to buy it. Here is the problem. The internet is moving to SSL everywhere, right? These users here have a sense of, I have privacy needs, so I'm going to use SSL all the time, and browsers and servers over here are adopting the same stance. And so now they're encrypting everything, and let's switch to a different color. And so now they're going out with SSL, and they're still picking up the malware, and they're bringing it back. And the problem is, none of these devices are good at SSL. Most of them don't even do them at all. In fact, very rare to find SSL on a DLP system. So how big of a problem is this? Well, just to give you a little personal example, I was speaking in San Francisco a couple months ago, and afterward the CTO of a Fortune 500 company came up to me and he asked me, "Hey David, I just finally got budget for this DLP system I've always wanted, and I'm going to drop it in, but it doesn't do SSL, and 80% of my traffic is encrypted." 80%, right? So that, if he were to put it in, and I hope he does, he'll only be able to see 20% of the traffic, right? That doesn't make any sense. But maybe 80% is a high number. What is it for somebody else? So we just finished surveying 1,000 security professionals to find out how much their traffic is encrypted, their outbound traffic. Most of them said 25 to 50%. So that means for all the spend they did on these devices, they are already missing between 50 and 75%. I'm sorry, between 25 and 50% of the traffic. And the final piece of this puzzle is that malware authors know this, right? If you were writing malware today, would you write something that FireEye could find? Of course you wouldn't. What's the easiest way to hide anything? Put it inside SSL. So that's why some analysts say by 2017, 100% of malware will be hiding inside encrypted connections. So what do you do? So that's the problem. That's the problem. How do you fix it? Well, let me give you three possible solutions. The first one is do nothing. This is what most people do, actually. Do nothing. Or worry. Maybe you stay up late or you take some kind of medication for that. Do nothing. And you can continue to do that, but you're going to miss more and more traffic that's encrypted. What's the second option? Well, in theory, right, for the devices that do support decryption, you could, let's say you had a web gateway that did, you could decrypt it here. There's a little unlock, right? Inspect it, re-encrypt it, send it over to the DLP, decrypt it, inspect it, re-encrypt it, send it over to, I'm not even going to finish that because nobody does this. Nobody does this, right? And one of the reasons nobody does this, actually there's 3 reasons. So let's call this one, I don't know, security, we'll call it SSL daisy chain. Nobody does this for 3 reasons. And those 3 reasons are, the latency, added latency of decrypting, re-encrypting, inspecting, blah, 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 would kill you, right? 2, for the devices that do these, they have an average performance decrease of 85% when they do SSL. And I'm not just making that number up. There's an NSS Labs report you can read from about 18 months ago showing the various performance decreases for each of these types of devices. This one is usually about 85% performance decrease. So unless you already bought one of these that has 10 times more capacity than you had planned for, turning on SSL would be, your things would be falling over all the time, right? So you'd have a failure case. Multiple points of failure constantly. Multiple single points of failure, let's call it that. And then 3, that's just inelegant. So nobody does this. I've never talked to any customer who does it, even on any one of these things, much less all of them. So what do you do? So how can we fix this problem going forward? You can orchestrate it. So check this out. Let's say you put an F5 in line for all your traffic going outbound, right? So now let's say Sally wants to go, I was going to say go out to the internet. Let's say she wants to go get some malware. She'll come down to here, to the F5. We will decrypt it, right? And then, now that it's decrypted, we can do things like, we'll send it over to the web gateway. Web gateway says it looks good. Let's send it over to, via ICAP to the DLP system, just to make sure she's not transmitting stuff out that she shouldn't be. Let's send it over to, for example, the administrator can decide for Sally or users like Sally, I want to send it to web gateway, DLP, the sandbox. I don't want to send it to IDS, IPS, right? Come back this way. And if all that checks out, then finally, then we send it out. And you might be thinking, well, hey, doesn't that add some of the latency back into it? Well, in the case where you're doing nothing, the traffic was transiting all these anyway. So there's really no added latency there. But you can start to do you can actually make this faster than the daisy chain you could do this one in parallel with this one. Does that make sense? So at the same time you're sending it to the web gateway, you're also sending it to the DLP, make it kind of a parallel processing thing. So that's super cool. And then if any one of these things decides the traffic doesn't look good, then it doesn't go out, right? So that adds a layer of flexibility. So let's say also that Vigo here is doing something that's not necessarily SSL or it's something that's not web related. He's doing some special kind of traffic, maybe VDI or whatever. There could be a different service chain here, which we simply pass on through, bypassing a lot of these things that would be sort of not really looking in the right place. And let's say that William here is actually a server. He's managing servers, and they're going out to the internet to pick up regular updates, right? Like Patch Tuesday or whatever. And the administrator can decide, you know what, I want those patches to go mostly through the IDS IPS, but not through, say, the sandbox or the web gateway, right? Because I kind of have an idea what that traffic is. That can go here, come back, get re-encrypted, and then get sent out, right? Perfect. So the administrator can define different service chains depending on the type of usage that's coming out of these, coming out of the data center, going out that way. This is how it's supposed to work. This is what people should be doing. And then once you have this kind of system in place, you're getting back that visibility. So let's take a look. Let's just sort of recap the benefits here. Getting back the visibility that you wanted, right? And then suppose the sandboxes. Let me just touch on this point. This is a fairly new technology. It's not the most, I don't know, mature. Let's say one of these goes down. Since of course you probably have two of them already. We can actually monitor these as a pool of servers, just like F5 does for everything else, right? And so if one of these goes down, we will notice and we'll send traffic to the other one. If they both go down, which could happen because as soon as one goes down, the load is doubled on the second one. If they both go down, we'll notice that too, and we won't ever send traffic there until they come back up, right? That's just standard node monitoring. That means traffic doesn't ever stop because outbound traffic is still hitting all the other parts of the service chain. We're just skipping these while they reboot. Whereas in the either two cases where you're doing nothing or the daisy chain, all traffic stops. Right? So this kind of adds you back some resiliency, or adds resiliency that you didn't have in the first place. I'm hoping I've spelled that right. Right? And then the third benefit, and I know I touched on this, was the flexibility to define different service chains depending on the different types of users. So this is actually the orchestration that you want to do for all your outbound traffic, and I think this is the way that we're all going to go be doing it as we move forward. All right, I hope you learned something today. Thank you very much.